x and y are independent exponential random variables with second moment of 32. So first of all, what is the second moment of an exponential random variable? Well, if the expected value of x is equal to theta, then the variance of x turns out to be the mean squared. So variance of x will be theta squared, and the expected value of x squared is going to be 2 times theta squared. Well, here we're told the second moment is equal to 32. So I can solve for my mean, and I can say that the expected value of x, which is what I was calling theta, is equal to 4. Now, x and y are independent, so what is their sum? The sum of two independent exponential random variables that have the same mean is going to be a gamma distribution. So we know that x plus y sums up to a gamma distribution where alpha equals 2, and theta, the mean of the underlying exponentials, is equal to 4. What's the probability that a gamma random variable is going to be at least 2? Well, I guess I want a condition on being greater than 1. So let's actually first figure out the general probability of being greater than some arbitrary t. The probability x plus y is greater than t. Because this is a gamma random variable, we have the connection with a Poisson distribution. This is going to be equal to the probability of the Poisson random variable with mean t divided by 4. So the key thing here, t over 4, the mean here is, I'm thinking if I'm looking at how many exponential random variables do I have to add up before the sum is going to exceed t, on average it's going to take t over 4 because each variable on average is mean 4, and so I expect to be able to squeeze t over 4 in there by time t. So I want to have the number of these exponentials, random variables I have to add up, the number of exponentials I can add up and still be less than t. I want that to be less than 2 because when I added 2 together I already got something that was bigger than 2, bigger than t. What's the probability of a Poisson random variable with mean t over 4 being less than 2? Well, it has to be either 0 or 1. So that's going to be e to the negative t over 4, the mean, e negative mean, times 1 plus the mean. All right. That more or less tells us what our answer is. And that means that the probability that x plus y is greater than 2, conditioned on x plus y being greater than 1, well, by the definition of conditional probability, I want in the numerator probability it's both greater than 2 and greater than 1. If it's greater than 2, it's greater than 1, so the second condition there is redundant. So I'm just going to look at the ratio of the probability x plus y is greater than 2 divided by probability x plus y is greater than 1, and plug 1 into those two expressions I just got with my 2t. So I have e to the negative t over 4, 2 over 4, times 1 plus 2 over 4. I'm dividing by e to the negative 1 over 4, times 1 plus 1 over 4. What is that going to give me as a final answer? Well, I'm going to end up getting e to the negative 1/4 times 6/5. And when I convert this to a decimal, it's about 0.93, 0.9345, or 46. That's going to round off to 0.93, and I have answer choice E.